Okay, so moving to our next question. This one is slightly tricky. So there is this file employee.java provided to us. The first one is to just take a look at the file and understand what we can from there. Let's take a look. This is the file. So we have a base class, which is an employee class. This, just a second, just wait. Okay. This has a function called calculate bonus, which prints this. Then we have another class manager, which is extending employee. So we can say that if this is my employee class, so the manager class extends it. If it extends it, that means whatever attributes are there in employee are also there in manager. But the point is there is no data member here. The employee class only has a function calculate bonus, and this function has been overridden in your manager class. So mainly that means if you create an object of manager class and call the calculate bonus function, it will call the one which is in the manager class because it is overridden. Okay. Now then we have a class developer which extends employee, printing a different message and having a different calculate bonus function. Then we have a class intern which also extends employee. So this is sort of the first observation can be it is hierarchical inheritance where we have multiple classes that so this is not a diamond, this is a triangle. Multiple classes inheriting from the same base class. So employee class and all these three classes are inheriting from it. Okay. So far so good. And then there is one function which is overridden in all the classes. If we look at the main function, now here is something which you might find slightly fishy. So we are creating an object of manager, an object of developer, an object of intern, but you look at the left hand side reference variables, all of these are that of employee class. So I don't think we have done something like this previously. You see, it's like, let's say I have a class called toy, and let's say I have a class called school. Then try doing something like toy t equals to new school. You will get an error. That doesn't mean anything. So note that you can also write this line as two different sentences. So you can write it like toy t, and then you can say t equals to new school. So do not get confused. What is happening here is first you are creating a reference variable of type toy. So in this particular line, there is no object being created. It's just a reference variable that is created. So a reference variable of type toy, which can point to a toy, that is t. An object will be created by this new school, but then the point is a reference variable of type toy cannot point to a school. That will show you an error. If you want, you can try doing that. Doesn't make much sense. So we are doing something similar in the same in this code over here. We are making an object of type manager, but the reference variable is of type employee, right? And similar to our previous example, probably this should also show an error. So let us check and see what is happening. Java C employee.java. So there is no compile time error. And when you run this file, it says main method not found. Okay. So I should execute class main here, right? Not the class employee. Class main has this entire thing. So I'll say Java main, right? And you see everything just works perfectly here. all the objects work fine. So if you say emp1 dot calculate bonus, it calls the bonus function of manager, second one calls the bonus function of developer, third one calls the bonus function of intern. And in this particular case it works. That is because if you look at object oriented programming languages, and that is Java, so in inheritance there is you can say this added functionality. In general, it is not allowed that the reference to one class points to the object of another class, but in the particular case of inheritance, you can have a reference of superclass and it can point to an object of subclass. So this is perfectly fine. The reverse cannot be done. So you cannot do manager M1 equals to new employee. Subclass reference cannot point to superclass object. So that is the thing. Your superclass reference points to a subclass object. And not just that, when you call this function calculate bonus, which is an overridden function, another example of polymorphism here, right? So calculate bonus function, it is working in three different senses based on whether you are calling it for manager or developer or intern. It shows different behavior based on which object is calling it. So that is the idea of polymorphism here, which is very different from function overloading. So remember, in function overloading also you will have the functions with the same name, but the catch there was your signature of the functions should be different. But in the case of method overriding, as we have seen so far, your function including the signature, everything is same, but these functions, one of them is in subclass and another is in superclass. Okay, so far so good. So we see this polymorphism. We also see that when you calculate, when this code runs, it does not call the calculate bonus function of your class employee every time. So it sees to which object this particular reference is pointing to, and accordingly at the runtime it decides which of the overridden functions to call. So as opposed to method overloading, which is called compile time polymorphism, because in that case, looking at the signature of your function, the compiler could decide which function to call at the runtime. But here in this case, it's called runtime polymorphism. Once the program is running, at that time, looking at the object, it is decided which function to call. So that is fine, but that is okay. But what is the use of this concept? So anyways, that is our major observation from the first part. Let's look at the question. What does it say next? Yeah. So we have figured out certain observations. Okay, so before moving further and enhancing on this code for dog, so maybe we can understand it further with the help of the dog example itself, or I'll first show you something for this employee class, and then we can you can try yourself the dog code, and if still you do not understand, then you can refer to the solutions. So I'll just tell you what is happening over here. I'll give you further idea. So what we were discussing is of what use is this? Why am I doing this particular way? I could have simply written manager here. Why would you want the reference of type employee here? I could have simply written developer here. My employee 2 is developer and my employee 3 is an intern, right? Still this code would have worked the same way. Furthermore, whatever we studied just now, that confusion wouldn't have been there. So if you still run this code, it still works the same way. So why would you want to create all these references of this superclass type employee and not just of these individual data types? So let's look into this. So I'll give you two examples of where this will be helpful. So take a look at this. What I'll do is I'm creating a new class called bonus, altogether a new class. So you can create an object of class bonus also. What this class bonus will do is it will have a function, let's say calculate. What this calculate function will do, so it's all a just cooked up example. This calculate function will take an object either of type manager or developer or intern. So or maybe even an employee also. So I'll say take an employee or manager or developer or intern. It can be any of these kinds of objects, and inside the body of this function for that particular object you should call the calculate bonus function, right? This function definition is not complete. This is here just as a problem statement so far. So class bonus has a function calculate. Whatever object is passed to this function calculate, it should calculate bonus for that particular object. So this is an example of what we have discussed before. When in one class you pass the object of another class as an argument, and what was that? If you remember, that was an example of dependency. So you can say that this bonus class, it is dependent on your manager class, your employee class, your developer class. It's a dotted arrow, or an intern class, right? Because it's going to use them into a function. So yeah, anyways, so coming back now, how shall I write this calculate bonus function? So before that, let me show you how we are going to call this function. So we have employee 1, employee 2, employee 3 of 3 data types. So I'm removing this line here. What I want to do next is, we have already created 3 employees. This new class that we created is the bonus class. So first of all, I'm going to create an object of type bonus, saying bonus b equals to new bonus. And now this object b, it is going to call the calculate function. Now the point is, if you pass a manager in here, you should call this function for manager. If you pass a developer here, call it for developer. If you pass an intern here, then it should be for intern. So as an example, if I pass EMP1 here, then you see I am passing a manager here. And if you are passing a manager reference here, your code here should collect that. So you can say manager M, right? So whatever is this EMP1 reference, it will be copied in this manager M, and then you can call M dot calculate bonus. Let us see if it is working or not. So as of now, your calculate function is only working for manager. Let's go back to the code. It says return type requires. So let me make it void. Okay. Right, so it works and it calls the bonus function for manager 20% of salary. Now the point is, I can also call this function b.calculate on a developer object, and I can pass emp2 here, right? Do you think the same code will work? Let's try. So I get this error. It says there is an incompatible type. Developer cannot be converted to manager. Why are you seeing this error? You have passed EMP2 here, which is a developer type of reference, but you do not have any corresponding function definition here, which takes developer as an argument. So one solution is you overload this function, right, as we have discussed before. So you can have the same function with varying signature where your data type is different. So I can say developer D, and then I can say D dot calculate bonus. Similarly, if you are going to call it for an intern, you should make one more overloaded function and say calculate intern I, and then you should call this same function for your class I. So I have this function calculate, which has been overloaded 3 times, and based on which object you are passing to it, it will call the same associated function. So I can add one more line here to call this function for EMP3, which is an intern, and let us see, the code works well. Right. So the code works well and everything is accomplished. But now the point is, can we smartly do something so that we can reduce the number of lines over here? You see, right now this company only has manager, developer, intern. Maybe in the future 50 more designations are added. Are you going to write 50 more versions of this calculate function? And even after you have developed that software and given it to the company, maybe later at some point company decides to, let's say, create one more designation, let's say a public speaker, and when the company comes up with that one more designation, this class bonus will no longer work because you will need to add one more calculate function for that particular public speaker. So what do you do here? So you can take the advantage of the same thing that we were doing here. So we asked, of what use is this, that instead of making these references of manager, developer and intern type, we can make all of them of your employee type. That is possible, right? So the idea there was simple, that if you have a reference to a superclass, it can point to a subclass object. So all I have to do is, you don't need a separate manager M, developer D, intern E. I can remove all of this and I can write these three functions as one simple function. I'll say employee M or employee E, and I'm going to say E dot calculate bonus. I'm going to remove all this. What happens now when you say B dot calculate EMP1? EMP1 is pointing to a manager object, right? But yeah, also its reference is of employee type. We will change this. EMP1 is an employee type of reference. EMP2 is also employee type of reference. EMP3 is also employee type of reference, right? So although you are passing EMP1, which is an employee type of reference, but it holds a manager object, and that is perfectly fine. So that way you don't have to write three functions here. Your employee type of reference can actually uh, point to any kind of object. So you don't need to write 3 or 30 or 100 functions. You can do away with a single function. Let's check whether it's working or not. It works perfectly fine, calling the relevant functions for each of the subclass. This particular functionality in Java that saves you writing a lot of code is called dynamic method dispatch or runtime polymorphism. Basically, at runtime, you are deciding which method to call based on the object. So this was just one example of how you can use this. Let me show you another example. Let me create a new class called employee list. So what I'm going to show you now, you can also call that a polymorphic array. Class employee list, whatever employees you are creating in this company, I want a list of them. So I want a list of managers, developers, interns, but I don't want separate lists. I want a list of employees in this particular company. So what do I do? Right, so if you were to treat manager, developers and interns differently, you would actually create different lists for every class. So you would do something like manager M list, and then you could do um, intern E list or I list, right? So one list for manager, one list for intern, and then somehow you would have to combine them. But is there a way that I can have a single list that can hold all the employees? So you can use the same idea there. The idea is you create a simple list called employee E list, and you can say equals to new employee 100. Now, what does this mean? This means that this particular list here, it can hold 100 employee references. And now, as you know, an employee reference can point to any kind of object. It can be manager, developer, or intern. So in case, let's say you want to add a particular employee to this E list. So let me write a function called void add, and in void add, you can pass any reference to an employee, any kind of object. It can be manager, developer, or intern. And I want to add that to eList. So I need to maintain an index to see where I'm running. So currently I'm going to take it as 0. Let me take it as 3 for now, just for the sake of simplicity. So you are passing an employee here, and as we saw before, you can pass any kind of object to this employee, any kind of subclass object. So what I can do is e list of index equals to E, whatever reference you have passed, and you can do index plus plus. I'm going to do that directly here. Right, so it will do E list equals to E, and after that it will increase your index by 1. To see how we have written two lines as one, you should be aware with this post increment operator here. So post increment means it will increment it after executing this statement. It will first assign E list of index to E, and then it will increment the index by 1. So the idea is here again you do not need three separate kind of lists for managers, developers and interns. You can simply have a list of employee references which can point to any kind of employee object. So this provides you a lot of flexibility into your Java program, saves you from writing a lot of additional code. If it is still not clear to you what is happening here, you can refer to the solutions which are coming next. Or again, by just looking at these examples, first you can try to solve those problems on your own.